Okay, in this next example, this is another chi-square test. This chi-square test we're going to look at now, the calculation for which is the goodness of fit for similar frequencies. Now this is a slightly different problem that the chi-square distribution can be used to test. So in this case, here's our little example. We're working on campus and we're trying to figure out which type of technology students prefer for ebooks and course materials. So you do a survey, you sample 90 students on campus, and you just ask them simply, do you prefer a smartphone, electronic tablet, or a laptop for use of your course materials, electronic course materials? Out of the 90, 21 tell you they prefer to get everything on their smartphone. Out of the 90, 41 tell you that they prefer to use an electronic tablet, and out of the 90, 28 tell you they prefer a laptop. 21, 41, and 28 add up to 90, right? Now, for goodness of fit for similar frequencies, their frequencies expected are calculated a little bit differently. It's very simple. Frequency expected is the same for each cell and is calculated as the n, the total n of your sample size, which in this case is 90, divided by the total number of groups. And this is 3 groups, or categories you could say, right? So for this sample, frequency expected is going to be 90 divided by 3. Very easy, 30, right? So in each of these cells, you expect, by chance alone, that you should have equal numbers of people for each one if there is no preference among students. All right, so given these numbers, this is very easy now to calculate chi-square. The basic formula is the same. The sum of the frequencies observed minus frequencies expected divided by frequencies expected. So let's do that now. Let's just, using these numbers, we'll calculate chi-square. So chi-square here equals the sum of, and we have frequencies observed, 21 minus 30, and we're going to square that number, right, and divide by the frequencies expected, right? And then we're going to add to that 41 minus 30, square that number, divide by 30, the frequencies expected, and then here, just trying to keep all this straight, squared, plus 28 minus 30 squared divided by 30. So what are our numbers there? Let's add this up. So we have here 21 minus 30 is 9, squared is 81 divided by 30, plus 41 minus 30, this is 11, right? And 11 squared, I don't have any doubt about where this is coming from. 121 divided by 30, and this is 2 squared, of course, is 4 divided by 30. 81 divided by 30 equals 2.7. Plus 120. 121 divided by 30 equals 4.03, and 4 divided by 30 equals 0.13, and we'll round that to 13. Then we add those together, 2.7 plus 4.03 plus 0.13 equals 6.86. Now, because your degrees of freedom for this problem were exactly the same as the previous chi-square example, in other words, you had 3 groups, degrees of freedom for chi-square is always the number of groups k minus 1, and so your degrees of freedom is 2, and if you look at the table, degrees of freedom 2 at 0.05 is chi-square critical value of 5.99. You should have printed out this table by now, so you can look with me there. And we see that our chi-square value for this problem is 6.86, right? and now you're ready to evaluate that result.